Being one of Earth's nearest neighbours at a mere 50 million miles away, Mars is quite handy to explore. But it's the fact that it resembles Earth more than any other planet which has helped fuel the belief that it could reveal the first signs of life elsewhere in the universe. Well, with me is the leader of Beagle 2 lander, which could be part of the European mission to Mars, Professor Pillinger, and a planetary geologist, Monica Grady. Good morning to you both. First of all, Monica, what is our fascination with Mars? Is it just that we're looking for signs of life?
Well, partly. Mars is very easy to see in the night sky. With a decent pair of binoculars, most people can pick it out. And ever since the first descriptions of Mars and things that were described as canals on Mars, quite incorrectly, we've been fascinated with the possibility that there might be life on Mars because of the signs that there has definitely been water on Mars in the past. And that's permeated our culture, our history. Think of all the science fiction that we know about Mars.
Yes, we can see this picture behind us, all that red rock. I mean, is that what you expected to see? When these pictures came back last year, were you pleasantly surprised? Did it tell you anything new?
It told us an awful lot new. The actual landscape that we're seeing here was taken from the Pathfinder mission of 1997, and it's very, very similar to the pictures we saw from the Viking missions of 1976. But we got additional information about the chemistry of the soil and of the rocks and of the different types of rocks that there are. If you can see different shapes, different colours looking in this panorama. So you can see that there has been a enormous amount of processing going on the planet, which has been brought about by water and also by volcanic processes. So it's a very Earth-like planet in many respects. And so that means that if it's an Earth-like planet in its geology, it's possible that it's Earth-like in some of the organic side of things and the possibility of life being there as well.
And that's the hope. But if I turn to Professor Pillinger next to you, you want to go again. You're working on this mission to go again. What more are you hoping to find out? I mean, if we didn't find it out this time, what's your mission going to do that this one didn't?
Well, this was actually very much a technology-proving mission. You asked the question earlier about the fact that it's very red. Well, the surface of Mars is extremely oxidizing, and that would destroy any evidence of the presence of life on the planet. So part of the role of Beagle 2 is actually going to be to burrow into the surface.
And find out what colour it was before.
No, not to find out what colour it was before, but to get into places where organic material might have survived, protected
so is that
from the harsh Martian environment.
Then? Is this the burrowing mechanism?
This is the Beagle 2 unfolding on the surface of Mars, deploying its camera. In a moment, you'll see the mole, which scurries across the surface and then dives underneath a big boulder to get a small sample that it delivers to the chemical laboratory inside the lander.
And for the reasons that Monica has explained, it's this planet more than any other that you want to send Beagle 2 to.
Well, this experiment will be able to look for water, it will be able to look for minerals that might have been deposited from water, it will look for organic matter, and it will try and distinguish whether the organic matter is in fact formed by biology. It's got some very intricate chemical tests in there that can do that.
Now, actually on the table here, it's very exciting. It's the first time a piece of Mars has ever been in the Breakfast News studio. I'm going to handle it very gingerly. Actually, oh no, I'm going to leave it there, otherwise we won't see it. I certainly don't want to drop it.
That's not quite true. We've been in this business since 1989.
Have you dropped it?
And much of the information that we know about Mars has come from meteorites like this.
So talk me through this, Monica, because I know that if this has landed on Earth, it may have been contaminated as it's come through the atmosphere.
Yes, this is a piece of Mars that's been chipped off during an impact. There are lots of craters on Mars, something's come down, hit the surface of Mars, knocked these rocks off. It's spent several million years getting from Mars to the Earth. It doesn't come in a straight line. And then as soon as it hits the Earth's atmosphere, the outer surface starts to burn up as it gets through the atmosphere and lands on the ground. Now, as it comes through the atmosphere and then lands on the ground, it's sort of possibly, for a start, it's all the atmosphere, the Earth's atmosphere is getting in the pore spaces.
Is that why it's not red?
No, this is because this is excavated from below the surface.
Right.
So you might have pollen grains in there, you might have all sorts of bits and pieces in there that the Earth has contaminated this rock.
So is it not very valuable then? Does it not tell us a lot?
No, it tells us a huge amount because we can quite easily distinguish those things from the indigenous Martian minerals that are in here. And in here are minerals called carbonates and sulfates, which have been laid down in water, and that water was on the surface of Mars. So we examine this rock and we can talk about the streams and the rivers on Mars and the temperature that they were at, the amount of carbon they had carried along in them that was trickling over the lava flows on the surface of Mars, just by looking at this rock. But if we want to look at any of the organic carbon, the sort of stuff which is a building block of life, that's very difficult to disentangle the terrestrial contamination from any Martian stuff. So we can't do everything from these rocks. We can do
so
a
you
huge
need
amount.
to be there. Monica, it's fascinating stuff, and we have no more time, Colin, I'm afraid, but good luck with the mission, and I hope we get many more rocks that tell us much more than this small meteorite. Thank you both very much.
Thank you.
Now, golf's most distinctive sound, the crunch of stars.